Okay, so let's start by looking at the Canvas page and show you where the important links are for lab and make sure you know where that is. Is it this one? No, it's this one. Okay, and let me just start here so you can see where to find it. Hopefully this is going out on the live stream. Okay, I had one fail on me at 7 this morning. It was not fun. Okay, so we're in week 1, the Canvas modules. And if you scroll down to lab, there's 2 pieces of information here. So there's a lab manual in the first link, and then there's lab manual appendices linked in the second one. They're both required today. It's really frustrating as a student. I appreciate it. I'm doing the best I can with the time I have available. So unfortunately, what happens is I'm going to link you to multiple places. I hate doing that. This is what I got to do. So if I go into here, this shows you the lab link, and this shows you where the manual is and all that stuff. All right, so if we go to here, if I click on this link, notice both of these links are right here. So this one tells you about the experiment. This one tells you about what I expect for formatting in your write-up. Again, the upper one tells you what the hell are we doing today, and the bottom one is the way you're supposed to write things for my class. All right. Now, it also has some other stuff like tricks on how to use certain sensors and things. I don't know if we'll use any of that with the online mode. So that said, I'm going to clear all these drawings out. If we go to this, let me see if I've already got it here. Well, I'll just start over. So if I go to the lab manual, something annoying, because this used to be a hard copy, I made it online when the bookstore was so bad. The page numbers aren't synced. So if I type in page 15, that takes me to page 13 in the write-up because there's a 2-page gap. So just know if I say a page number, you might have to add or subtract 2 pages from that page number if I screw up sometimes. Okay. And then, not anymore. Yeah. So I make so many changes, it's just faster now. But you could print this out if you want, but I wouldn't bother. Yeah, more on that later. Okay. Yeah. We're not going to use most of these. More on that next week, I suppose. Okay, so here's the idea. We're going to learn about experimental uncertainty. We don't all have the same equipment. So we're going to have to make some changes, and it's important that you pay attention to the changes. So if you have a notepad, you might be making a note of stuff that I say is important. Okay. The idea is this. When you take a measurement, it's never perfect. We want to know how uncertain it is. There are many different ways to describe uncertainty, and these are some of them are listed in here. So we're going to try and do our best to have you read this, but usually what happens is it's best for you to get the data that we're supposed to take today, then reread this and kind of say, okay, what does my data have to do with this document? Now, here's a specific example. They're talking about, let's say somebody took 5 measurements of X, and maybe they were all in meters. They're going to, how to take the average. Okay. Today, instead of measuring X, we're going to measure this thing called G. All right. So what we're going to do today is you take a data set instead of these stupid 5 numbers out of thin air, and you're going to see how this sample problem applies to your set of numbers. Got it? So you're going to get some numbers here, and you're going to do the math that they show on this page. They show you how to get the average. On the next page, they show you how to do this thing called standard deviation. And it looks really scary, but I'll show you some shortcuts. And then they say, well, what does the standard deviation mean? So in this report, it tells you what the standard deviation means. And then in a conclusion question, it says, well, this is the claim. Does your data set match up to this claim pretty well? So that's our goal, is we want to see if we all take data and we have like 68, or if we have 20 data points, do 68% of them, or about 13 or 14, fall within one standard deviation? So we're going to do an experiment, a real experiment, and check that. We go on. It says, what does this mean? And there's an interpretation of all this. So you could read all this later after we get going. And then it talks about somewhere down here, sorry, I'm scrolling so much. It talks about standard error. So in short, we're going to try and learn about average, standard deviation, and standard error. They're related, but they're not all the same. And so, and notice today it says, okay, you're going to be split into groups, and one group is going to get an average. That's what this little bar symbol means. This means the average value of V, and this is the standard deviation of V. If you don't know what that symbol is, it's lowercase sigma. You're going to hear me say sigma sometimes, okay? And notice sigma has units. Anyways, all right. The idea is we're going to get data from each group. So about hopefully about 7:30 or so, you're going to have your data collected, and we'll give all that information to Trey, and then Trey will give you back everybody else's data so that you can do this part of it, the standard, the standard error part. And so, and it says, what does all this crap mean? Blah, 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 blah. It explains some stuff. And then it says, here's the summary. Great. So that's the theory, and that's where to find it. So I want you guys to be able to read that document and use it on your data set. How do we get your data set? That's the next part. Let's go. Whoops. I want to go back to share screen there. Sorry about that. All right. So here's where we have to be careful. And if you've got some notes, this is where we're going to have to be a little bit different on this page. So we're going to calculate, instead of T, we're not doing T. Oh, that's so sloppy. Not T. We're going to do G. G is a physics constant. You don't have to understand the physics that much. It's more about understanding this error analysis today. I don't care about the physics. We're going to learn this next week. So what I want you to do is we're going to see everywhere there's a T on this page. So for this question, we're going to replace the symbol T with G. And it's not easy for, see, there's another one. So basically everywhere on this page, this is page 21 of the handout, which is page 23 of the file. We need to change all the T's to the letter G. Now here's the basic experiment. Whoops. Now, I want you to find some object in your house that is dense. If you have a baseball, cool. A golf ball, cool. If not, a shoe. Or somebody earlier did a water bottle, and I want you to drop it from a known height. More on the height in just a minute. And then I want you to do the same thing with a crumpled up piece of paper. Now, everybody has to do the crumpled up piece of paper. And then over here, just use whatever dense object you have, a bottle, a rock, or whatever. But we need to drop it from a known height. Okay. Now, here's one trick you could do. If you've got a measuring tape, great. Try to measure out 2 meters. If you don't have a measuring tape or a ruler and you're not really, if you want to get this over with, which is recommended, you could use a piece of paper as 11 inches, right? And so if you literally stack pieces of paper up 7 times, that'll get you to 77 inches, right? 7 times 11. And that's approximately 2 meters. Another thing you could do is use a standard doorway. That's a door back there. So you could use a standard doorway and check the height with a piece of paper, and you get this thing over with if you don't have a ruler, right? Not everybody's got a ruler or a meter stick or a measuring tape, but if you got a measuring tape, that would be the best. Okay, now here's the idea. Again, the physics is not that important, but here's a physics equation that we're going to learn about next week. The change in vertical position, which is a vector, is equal to half the acceleration times time squared. If we drop it from rest, the initial velocity is 0. And it turns out the vertical displacement, excuse me, if this distance is h, the change in height, the change in position, vertical, that's what this symbol means, more on that next week, is negative h, all right? The acceleration due to gravity is not g. The magnitude of the acceleration due to gravity is g, right? It's falling downwards. So the acceleration is g this direction. As a result, there's a negative sign in the displacement. There's a negative sign. These cancel. You rearrange this crap. This is our formula to compute this stupid thing g. All right? More on that next week. But the idea here is if you can record a height and a time with a stopwatch, your phone, you could use an online timer on a website. If you get that information, we can then compute this value of g. And I want every single student, you're probably tired and zoning out. Listen right now, okay? You need 5 values for the dense object and 5 values here. They can all use the same height. So basically you need 5 values of time and you need 5 values of time for the crumpled paper. So each student has to get 10 times, and that's the data. It's super easy. So let me pause. Questions? So far, so good? Okay.
Sorry again.
Oh, question.
Go ahead.
Oh, who is
I
that?
was just wondering, like, are we plugging in the numbers right after we get the data, right?
Yeah, and I'll show you more on that in just a second. So actually, let's do it right now. Oh, and let's see the chat. Yes, the magnitude of acceleration is g. So take a look here. So now what we want to do is, the other thing that we're trying to do is learn how to write this up in a group fashion. So I have a couple of tricks I want to show you. So let me do a screen share here. Oh, there's another chat. Yeah. Okay. All right. Sorry. Let me go into here. All right. So now I'm going to show you how to make an Excel spreadsheet. And remember, I'm live streaming this. So if you forget all this crap, you can watch it later. All right. So let me just clear this out so I start from scratch. All right. And I'm going to make this a little bit bigger. So, zoom. Sorry. Oops, wrong way. Okay. So now you probably don't know all this stuff. I'm going to focus on this stuff next week. For today, I'll teach you. If you ask a question because you forget and you don't have time to watch a live stream, I'll come back to the breakout rooms. Trey can show you all this, but I'm going to show you all the tricks right now, and then I'll teach you them in detail next week. You're going to have a height, right? And it's going to be in meters. Notice I put in a space right there. Now, typically what we do is the units are not italicized. The variables are italicized. So I hit Control I there, or you could just do this, whatever you want. Okay, so let's say your height ends up being 1.97 meters. Now it starts to get a little bit sloppy, so I want to organize things. I'm going to hit this button or Control A, and I'm going to center everything. That just means it's a little bit less distracting. Maybe I'm going to do some times. So watch what I do. I write everything without any formatting. Then I go back and italicize what's important, the variable. Let's say I want to calculate G. It's meters per second squared. Okay. This is not good enough. I don't want this. This is not acceptable for a lab report. Part of being a scientist is communicating properly, and you just got to learn one little trick here. So I want you to highlight the number 2, right click, format cells, superscript. If you needed a subscript, you could do that. Okay. I'm not done yet. G is a variable. I'm going to italicize it. There we go. Now take a look at this. Let's say you record some times. Watch this one. Let's say the time is 0.60. When I hit enter, where'd that sig fig go? Zoom. Right up here, I call these the sig fig buttons. So if I do this, I can click back into here and I can just play around with these buttons and add or subtract zeros as appropriate. This is important. We're doing science now. Every sig fig means something, okay? So, okay, let's say those are the times I got, all right? Now, let's say I want to compute the value. We know from our work on the whiteboard earlier, from what I tell you, that, what did I say? G was equal to, what was it? 2H?
2H over T squared.
Thanks. 2H over T squared for today's lab. So what we can do is we can learn how to have Excel do all the work for us. We do not want to compute these one by one. So what do? I go into this formula. Check this out. Equals. You have to hit equals. That says, Excel, do something for me. Then I say, well, it's 2 times the value of my height. So I'm using that cell A2. I could either type A2 or I could just click on it and note, whoops, you have to have the star there. And now I could divide by the time squared. Well, here's the time. Now, if you know what mistake I just made, just be quiet for a minute. Okay. So this looks great. Now I want to show you something here. Notice right now my cursor or the little mouse button. See how it's a white plus sign right now? Look what happens if I put it in a different spot. If I put this right on the edge, I know it's very difficult to see, but it becomes a black plus sign with arrows. Look what happens if I go to the bottom right corner. It becomes a black plus sign with no arrows. So now I'm going to click and drag it down and it fills down. Oh crap, it didn't do the calculations. Why not? If I click into here, when it fills down, every single cell fills down. If only there was a way to keep that from happening on this special cell A2. So let's try this again. Watch this cool trick. Equals 2 times A2. Now I'm going to hit the F4 button. That puts dollar signs on here. You could just type it as well. You could type $A, $2. Then I'm going to divide by the time squared. And now when I fill this thing down, it works. Oh, I hate those sig figs. Let's play around with them and just make it look prettier. Okay. And so the idea, that's pretty cool, right? Great. There's actually another way you could do this. You could click into this cell and type height. And actually, maybe I'll call this, since there's 4 students in a group today, or 3 or 4, maybe I'll call this height _1. Now, remember, I cannot use H1. I have to use H _1. H1 would be this cell right here. So check this out. I could actually do this one more way. I know this seems crazy that I keep redoing it, but there's a reason you might want to do that later. This is equal to 2 times, what did I call it? Height 1. Look at that. It knows what it is, and now you don't need the dollar signs. Divided by this, quantity squared. And I could fill this down. And so the idea is you do not want to do 20 calculations by hand. You need to learn how to use Excel. And this is your chance to do that. So that's one thing you could do to get your data very quickly. What if I want the average? Take a guess what I should do to get the average. What's the first thing I should type? Let me check here in the chat here. What's that? Yeah, equals. So I type equals. What do you guess the command is for average?
Maybe.
Close. If you start typing it, it'll tell you. It's just the word average. Now you have to put a parenthesis and then highlight the numbers. Good to go. There's a thing called the standard deviation. Any guess what you need to type for that?
Standard deviation?
STDEV. Now, one of the things that students sometimes screw up, when you're doing a standard deviation, you want to highlight the numbers, but you do not want to highlight the average. The average is not part of the standard deviation calculation. If you don't know why, read the lab manual. Yep. Yeah. Okay. Now, and then standard error, this might be, whoops, this one's trickier. I'll let you read, but I think, I can't remember exactly. I think it's the standard deviation divided by the square root of how many things you have. Now, I could say the number 3 was how many measurements I had, or I could get spicy and say count and make it count them. That way I don't have to remember how many are in there. This may seem cheesy for 3, but imagine if you had 178, right? And then I could fix up the sig figs. Now, you don't know this yet, but usually these are all error calculations. Error calculations should have 1 sig fig. So usually you round them all the way down to there. And this says that we are off in the ones column. So this means our value of G was, oh, wow, I got 9.81. That's ridiculous. But it's plus or minus 4. So it's about 10. It could be as high as 14 or as low as 6, basically. Let me see if that was something in the chat there. Okay, cool. So that's how you could work with Excel. Again, you're going to forget all this, but you're going to have the live stream later. Next, let's show you how to do a Word document. Now, you could use Google Docs as well, but I'm just going to make up something here. Okay. Now, eventually, you want to learn how to use the equation editor. Now, check out how cool this is. If you, whoops, sorry. Oh, is that a chat question there? Yeah, right. Okay, so check this out. Let's say we want to learn how to type this equation, G equals this. The first thing I do, well, there's a couple ways to do this. You could hit Insert. Come on, computer. Oh my gosh. And you could put in an equation. You could also just hit Alt equals. And then I could just start typing like V initial X squared equals 2 times square root of, let's see. Oh, whoops. You could do, let's do it like this. What if I wanted a Greek letter? I hit this slash and I type alpha. That's a Greek letter. What if I want to do a fraction? I could do it this way. What if I want to do a square root or something? There's different ways to do this, but you could go up into here and hit the square root. Now, this works really well, and it's so fast. I like working in Word. I know a lot of you students really like working in Google Docs, right? Because now one of the things that Google Docs is bad at as a default is equations. But I did try to put some instructions in here. This is an equation editor. It's not exactly the same as what I was showing you, but if we want to use Google Docs, this equation editor might be useful for you. And here's a training video on how to use the equation editor in MS Office if you need that. So anyways, that's how you could do your write-up and all this stuff. All right. Okay. So now let's see here. Where were we? We've talked about today's experiment. We need to do G, not T. We've talked about how to do an Excel spreadsheet. We've talked about how to get the average, the standard deviation. And then to remind you, at some point, you need to know, okay, dude, what do you want me to turn in so I can get the heck out of here and go to sleep? So that's right here. Okay, so this was all getting started. And then if we go back to here, the checklist to turn in. Come on. I hate Canvas. It always makes me start over and I have to wait for it before I can scroll. So this is a checklist. Now, my checklist might look different than yours. If you're able to bring yours up on Canvas right now, that's fine. But I've made some significant edits. And I want to point those out based off the last section. I'm trying to make your life easier by cutting stuff. So I want to point out the following thing. Bullet 4 is now not required. I had a whole bunch of instructions there earlier in the day. If you already opened this link, you may see a bunch of stuff in bullet 4. Make sure you write this down right now. Bullet 4 is no longer required on the turn-in page. This used to say every single group member. So in bullet 2, you only need photos for one student taking data. Got it? Now, if you might think you know how to write a procedure, and I bet you do, but you may not write it according to the way I want it. So, and I just take off points if you don't do what I want. So to do that, let's go back to here, right? And I'm just trying to get you used to this. If you go to the lab manual appendices, right? Let's see, that's probably right here. This has got all the links on how I want you to write. Okay. And so a common mistake is people think procedures should be in a bulleted list, -2 points. All right. So it's important that if you read here, all the pages are described here, like how to do a procedure and how to do data and calculations. So we're doing data, but not calculations today. And then how to do discussions. Sometimes if you actually read the instructions, you may save yourself time. So when you get to those parts, great. We are turning in one report per group. I'm going to assign the groups in just a minute when I close the breakout rooms. Now, that's my kids out there screaming. I don't know if you could hear that. I don't know where I was, but yeah, so one report for a group. And then, yeah, those of you that have kids know what it's like, right? You're going to see this. Yeah, whatever. Let's get to work. All right. Trey, anything you want to say?
No, I feel like that's pretty good to start for now.
Okay.
And
So
if anyone has questions,